Problem 167, toSum the second input array is sorted. So presumably there was toSum, the original toSum, the first, where input arrays was not sorted, and now the input array is sorted. Okay, so what's going on is we're given an array of integers, and it's called numbers, the array. And that array is sorted in a non-decreasing order. Now, we are to find two numbers from this array of numbers that sum up to a specific target number, which is given. Right? And they tell us that we should return a tuple like this, so an array of two elements. But these indices have to be one-based indices. So if the first element was matched, and so the first element and the second element add up to whatever target, instead of returning 0, 1, right, we should return 1, 2. Okay, so one-based indices. So notice that this confusing little string here that we're given a one-indexed array, it's a bit confusing because they do not mean that somehow this array will be indexed from 1. So it could also be interpreted that, you know, the 0th element is just injected at some sort of dummy placeholder element here, which is not the case. I'm just saying this because this is a slightly confusing way of saying all of these things here. Return the indices of two numbers, index 1, index 2, added by 1 as an integer array. This added by 1, this stuff is a little bit confusing. So the tests are generated such that there is exactly one solution. Should not matter to us. This may matter for testing, and I think I've seen this in another problem. They give us some sort of constraint which does not really play any important role. At least I can't see how you can use this to optimize your solution. But they promise us that there will be only one solution. I don't think I care about this, but you may not use the same element twice. This is important, right? This will affect how we write the program. Your solution must use only constant extra space. So no more arrays other than numbers. We should not introduce any more arrays. So I've prepared this little array here. It's sorted in non-descending order. Target is 12. Now here there are multiple kind of solutions here. For example, 3 and 9, 3 and 9, okay? But I will be looking for the outermost solution, okay? And then, for example, even 4 and 8, these add up to 12. But if you were to kind of if you were to collapse all of these similar numbers together, you can easily see that there will be an outermost solution always, even if there are multiple solutions. These solutions would be kind of nested like this. So if you condense all of these numbers that are the same, and right, because let's say if you have this solution, if you then move one of these numbers, right? If you were to, for example, increase this number, right? If you were to move this number to the left, it would increase because you've condensed all of the similar numbers. So this will be a larger number. That means you have to decrease this and move it to the left, right? So a nested solution. Or if you were to move this leftmost number, the first number, to the left, then the sum would decrease strictly. So to get it back to the target, you would have to move this right number to the right. So again, a larger solution. So again, you have a nested situation. So you have the largest, let's say, solution. Well, considering that you kind of ignore the differences between these same numbers. Because see, if all of the numbers are the same, for example, right, and your sum is 4, then here is the largest solution. But I mean, you have a whole bunch of overlapping solutions here. So that's kind of too chaotic. But still, you have a largest solution, right? widest, or the biggest, widest, whatever, the most nesting solution. And that's what I'm going to be looking for, the widest solution, the one that contains every other solution. So why don't we do the following? Yeah, this problem is about 2 pointers. So let's start from with 2 pointers, I and j, at the opposite ends. Now, if we add up these numbers at these locations, right? Oh, and it's so if it adds up to 12, which it accidentally does, then we found our match. If it is over 12, then we need to reduce the sum and move j to the left. If we are under 12, then we need to increase the sum and we will move I to the right. Okay? And by doing so, we can never miss that widest solution. Okay? It's not possible. Let's say this was the widest solution, yeah? For example. Now, if this is the widest solution, then let's consider the moment when we first enter this solution. So if either I touches this bit here first, or j touches this bit here first. Okay. So, oh, I deleted it. Let's say this is the case. Let's say I comes here first. Okay. Now, notice that j must be somewhere to the right. Now, I is not going to budge from this place until j comes to 9, because since j is outside, that means, well, that whatever j is currently is a larger number, right? If it's the same, it does not matter. I mean, we're talking about the widest solution. So j is a higher number because the array is increasing, non-decreasing, right? And therefore, because this is a solution, then this cannot be a solution, right? And we'll keep reducing j according to our algorithm. And at some point, we'll keep reducing it until we get to here. And at that point, we'll find that solution. So I think I've probably convinced you, probably it wasn't very articulate, but I think if you spend a little bit of time on this, you'll see that this is correct. Right. So let's write, I went to typescriptlang.org to write this. So how am I going to do it? So 2 variables, I and j. Let's create I equals to 0, j equals to numbers length minus 1. So that's pointing to the last element. And then while I is less than j, now they told us you cannot use the same number twice, right? So that means strict inequality. While I is strictly less than j, here is what we're going to do. If why don't we compute delta? Constant delta would be numbers I plus numbers j minus target, right? So if delta is less than 0, if it's less than 0, that means target is larger. You know what? Yeah, let's do it. So if this is less than 0, then we are under the target. And under the target means I needs to be increased. Now, otherwise, if delta is above 0, then j needs to decrease. And otherwise, just return. What should we return? All right. We should return I plus 1, j plus 1. Yeah. And if we come out of this, we should throw throw new error. Cannot find the two numbers. Yeah. I think that's it. Okay. Let's see how this performs on the pretests. Okay, the pretests are fine. Let's submit it and see. Beats 30%. Beats 30%. Really? Okay. So other solutions are faster. Well, there are clearly significantly slower solutions as well. I mean, these are n² solutions probably that people have done. Ours is O(n). We're going to traverse this array only once. And people did significantly faster. I mean, a lot of people did faster than this. So 65 almost % did faster than that. No, I mean, that's a decent solution. This is fast enough. Seems fine to me.